our discussion on the existence of this composite function fg. And to do that, I need you to have a little bit of imagination. I want you to try to imagine together with me all the possible scenarios that these two functions can be combined together. So the first way that I think they can be combined together is definitely what I've just drawn here. So I'm going to just redraw this one more time. Something that is like this. X will go into G, then whatever that comes out from G will go into F. So this is one of the possible scenario. Another possible scenario is X will go into G. Then whatever that comes out from G is going to be exactly the same as what F can receive. So another scenario is this, where here is exactly the same as this. So I'm going to just draw it as if it is two parallel lines. And the last possible scenario, and I think now you get it, okay? So I think it is possible for you to imagine it for yourself that the last possible scenario is going to be something that is like this. First, X will go into G, then whatever that comes out from G will go into F. So we have three possible scenarios that is like this, which is the one that you just feel something is not right about the way that they're combining. And I think you would agree that it is number 3. Because in number 3, whatever that comes out from G, yes, it will go into F, but only part of it will go into F. Because some other parts will actually be spilling all the way outside, outside of F. And this is definitely not the way that I want to build a machine, because whatever that comes out from G, some parts of it will actually, go outside of F. I want everything that comes out from G to go into F. Which means that this is the case that I say that nope, so which means that if this happens, the composite function will not exist. The composite function will exist for number 1 or number 2. And let's try to take a look at this scenario for number 1. For number 1, what I'm trying to look at is a scenario where the output of G, which is the range of G, is going to be strictly within what F can receive. So it is going to be a strict subset of the domain of F. This is number 1. And for number 2, if I were to analyze what that is here, like how I have tried to draw it, what I'm looking at is that the range of G is exactly the same as what F can receive. And I know when this happen or this happen, the composite function can exist. It is possible for them to be combined together without having a scenario that is like this. That is why the condition for the composite function fg to exist is that the range of G must be a strict subset or equal to the domain of F. And this will help us to determine whether this particular composite function